So today we continue our unit on transformations. So far you've learned about 3 types of transformations. First, you learned about a translation, which is the shift or slide of an object across the coordinate plane. You've learned about reflections, which takes an object and flips it over either the X or Y axis, resulting in a mirror image of the original object. And then you've also learned about rotating 180 degrees, which turns the coordinate upside down on the coordinate plane into the opposite quadrant. So today we're going to learn about rotating a figure 90 degrees. In order to rotate a figure 90 degrees, you're going to switch the X and Y for each coordinate and apply the signs of the quadrant it will turn into. So let's try a bunch of these together because this is one of the more challenging types of transformations to perform. So first we're going to do SCI, which S is graphed at 0.11. Again, remembering to label each point as we're graphing. C is at 7,1. And I is at 4,6. Resulting in what looks like an equilateral triangle. Equilateral because it looks like all the sides are the same. Take your straight edge and connect your points. Okay, and we're going to rotate it 90 degrees clockwise. Now remember, it says switch the X and Y and apply the signs of the quadrant it will turn into. So a 90-degree turn is a quarter turn. So instead of rotating around 2 quadrants of the coordinate plane, it's only going to rotate into one quadrant of the coordinate plane. And we are going 90 degrees clockwise, so in the order of a clock. So if you think about that, that means this triangle is going to rotate clockwise into this quadrant. So it's going to go from the first quadrant to the fourth quadrant. In the fourth quadrant, the signs are positive and then negative. The X's are positive and the Y's are negative. So that's what this means. Apply the signs of the quadrant it will turn into. So I'm going to start by rewriting my coordinates. So S prime, if we switch the X and Y, it's still 1, 1, but then we change the signs to fall into the fourth quadrant. So we have +1 and -1 for S prime. Then C prime, switching the X and Y results in 1, 7. And then applying the signs positive, negative, so +1, -7. And then I prime, switching 4, 6 to 6, 4. And applying the signs, positive, negative, so 6, -4. So now we can go ahead and graph those. S is at +1, -1, S prime. C is at +1, -7, making that C prime. And I is at +6, -4, I prime. Go ahead and take your straight edge and draw your lines for your shape. And you can see how this SC was rotated to form this SC. And it's kind of like if you took your paper and turned it a quarter of a turn, you would wind up with this shape. So if it helps you to visualize it, you could always shift your paper and think about where it should land before you start actually graphing it. So what is the new coordinate for C prime? Well, we already did that. It's 1, -7. Okay, so let's take a look at another example together. So in this case, we have MARK. So we'll start by graphing those points. M is at -3, -2. A is at -1, -4. R is at -3, -8. And K is at -5, -4, giving us a kite-like shape or a rhombus. Go ahead and take your straight edge and neatly draw your shape. Okay, and now we're going to go ahead and rotate 90 degrees counterclockwise. So think about what we said before. If we're rotating clockwise, we would go up into the third quadrant or into the second quadrant, but we want to go counterclockwise, which is going to bring us over to the fourth quadrant again. So again, in the fourth quadrant, we recall that the signs are positive, negative, and we can start to rewrite our coordinates. So M prime, switching the coordinates would be 2, 3. And then applying the new signs is going to be positive 2, negative 3. A prime, switching the coordinates would be 4, 1. Applying the new signs is going to be positive 4, negative 1. R prime, switching the coordinates is going to be 8, 3. Applying the new signs is going to be positive 8, negative 3. And then K prime, switching the coordinates is going to be 4, 5. And applying the new signs, positive 4, negative 5. So now we can go ahead and graph those. So again, we have M prime is going to be at positive 2, negative 3. A prime is going to be at positive 4, negative 1. R prime is going to be at positive 8, negative 3. And K prime is going to be at positive 4, negative 5. Resulting in another rhombus, but now turned on its side. And you can see how all the points from the blue shape were rotated 180 degrees to get that green shape. And although they don't look quite congruent because my graph is not super neat doing it on the computer, they should be congruent. K to A is exactly 4 units across. K prime to A prime is exactly 4 units across. K to M is 6 units up and down. K to M here, or maybe it's R, sorry, R to M is 6 units up and down. R to M here is 6 units across. So it has been rotated 90 degrees counterclockwise, the opposite direction of a clock, resulting in a congruent shape. All right, so we're going to do 3 together, and then I'm going to give you some hints for 4 and 5. So for number 3, we start by graphing A1, 2. R5, 2. And T3, 8. Resulting in an isosceles triangle. Okay, and they want us to rotate it 90 degrees clockwise. I want to actually change this to counterclockwise because I don't want to fall in the fourth quadrant again. We've done a bunch where we keep falling in the fourth quadrant. So let's change this to counterclockwise. It's really difficult to write on this, so excuse my messy handwriting. So we're going to do 90 degrees counterclockwise, which rotates this direction. So we're going from the first quadrant to the second quadrant. And in the second quadrant, the signs are negative and then positive. So we can apply the rule to our coordinates. So our A, if I switch the signs, A prime, if I switch the coordinates, it's going to be 2, 1. And then apply the new signs, it's going to be negative 2, positive 1. R prime is going to be 2, 5, switching the coordinates, and then applying the signs, it's going to be negative 2, positive 5. T prime, switching the coordinates, is going to be 8, 3. And applying the sign, it's going to be negative 8, positive 3. So we can go ahead and graph those points. We have negative 2, positive 1 for A prime. Negative 2, positive 5 for R prime. And negative 8, positive 3 for T prime. resulting in an isosceles triangle that has been turned on its side. And if you look, this AR has been rotated 90 degrees, forming this AR. Now it went from horizontal to vertical, okay? And these two shapes are congruent. They may not look too congruent because of how I drew them, but A and R are 4.4 units across here. A and R are 4 units across here. From the base of the triangle to the tippy top T is 6 units up. From the base of this triangle here to the tippy top T is also 6 units across. So that is the gist of rotating 90 degrees. It's tricky, but I think you all can get it. Make sure you're changing the X and Y and then thinking about which quadrant it's going to fall into, and then applying those new signs. So the next two are a little bit challenging. I'm going to give you a little bit of a hint before you move on and trying them on your own. Notice they both say 270 degrees. Okay, so think about that. If you're rotating 270 degrees clockwise, that's doing 3 90-degree turns. Okay, so we could just do the opposite. Instead of rotating 270 degrees clockwise, think of it as rotating 90 degrees counterclockwise. And same thing over here. Instead of rotating 270 degrees counterclockwise, that's just 90 degrees clockwise. Okay? It would be silly to go ahead and rotating it 3 times 90 degrees. So you just have to know that it's the opposite 90 degrees in the opposite direction. All right? So good luck. Go ahead and try those two and the algebra problem for number 6. I'll be around to help you out.